estimating roots. Now, roots don't just live with perfect squares. So it's not just the square root of 9 or the square root of 121. We can take the square root of any number because any number will have a factor that's equal to itself that we can multiply together to get that number. So if we're looking at estimating roots, let's try this with just estimating the square root of 10. Now when we do this, when we're estimating root, the one thing we're looking for is we're looking for the nearest integer. The nearest integer. So it's not whether or not you've gone past it or it's less than. This is not the Price is Right. There's no going over. It's whatever number is closest to it that was the perfect square. So for square root of 10, if I just put a simple number line here, let's just put this line on. You don't have to make the line, but I'm putting the line on for the visual here. If I think about the square root of 10, what two perfect squares bracket the square root of 10? I've got the square root of 9, and then it comes to the square root of 16, right? Square root of 16. Now what I'm looking for here is which one of these values is the square root of 10 closer to, right? And if we were to make a number line for this, it would go square root of 9, square root of 10, square root of 11, square root of blah, 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 blah. So I'm going to say that the square root of 10 lies closer to the square root of 9. Now when I'm estimating the square root of 10, I'm choosing the nearest integer. And the nearest integer then is the square root of 9, which means my value is 3. Because the square root of 9 is equal to 3. So this is sort of a double number line, and if I draw that second number line in here, let's put it right here. Yoink. Oh, my ruler moved, sorry. We can describe this as 3 and this as 4. And that 10 lies here, which means it's closer to 3, so the nearest integer for the square root of 10 is 3. Let's look at, oh my God, where did I put my eraser? Okay, I have it together now. I found my eraser. Here's some examples. Let's do some examples together. So we're estimating the roots here. Now, I put an equal sign, but it's not an equal sign, right? So let's change that because we're estimating, and because we're estimating, we're going to use those double waves. I think I made a mistake with that before. It's double waves. So this means an estimate of the square root of 36. So just to go back to what we were doing, square root of 35. Square root of 35. So we've got the square root of 36 is the perfect square north of it or greater than. And the square root of 25. So where's 35? It's way closer to the square root of 36, which means we would estimate it at square root of 36 being 6. 47.8, what is the nearest perfect square less than that? Is 36. The nearest perfect square more than that is 49. So which one is this closer to? Is it closer to 36 or 49? Definitely 49, which means it is approximately 7. Now we're capable of doing this with cube roots too. So with cube roots, now we need to know our perfect cubes. So our perfect cubes, let's go over this again real quick here. 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third is 125. I've got 50 there. So it's between the cube root of 27 and the cube root of 64. Oh, this is a tough one here. All right, so it's 23 more than 27. 27? Yeah, 27. I got my cubes and squares mixed up. And 14 less than 64, which means it's nearer to this. So then we are going to say this is approximately, now I'm going to write the wrong answer real quick. It's approximately 8. Why did I pick 8? What mistake did I make just there? You're absolutely right. I took the square root of 64 when I needed the cube root of 64, which means that the cube root of 50 is approximately 4. Don't forget, when we're doing approximations or estimates, it is estimating roots, not approximations, Mr. Romanovich. We're estimating roots, not approximating roots, so sorry. Don't forget, what we want is the nearest integer, and you're going to use the lower perfect square and higher perfect square to determine what that integer is.